What's going on, everybody? Today we are going to continue our OpenGL tutorial, and we are going to learn about the shaders. Now, what is a shader? Is shader when we draw an object, yeah? We draw an object, we tell our GPU to how to draw them. Like, we have mainly today vertex and fragment shaders. Vertex shader basically controls how our vertex will be drawn, and like their coordinates and so on. And basically all you need to know right now is that it controls the coordinates of the object and manipulates how they are shown, not how they act, but how they shown. Their act is still on a still controlled by us. Now, and fragment shader just tells how to draw them. Now, and let's begin. So first thing we're gonna do is define colors. That's the easy part. And only for this video we'll do this. Do not do this in a professional or way if you want to make a game or something like that. Do not use this tactics. So we have our rectangle. I renamed our triangle to rectangle here. And we write like this. Yes. Even if our color system of OpenGL uses RGBA, and we have to write red, green, and blue, and alpha 2 in these numbers, yeah, from 0 to 1. Do not you got it, I suppose. You're not just copy pasting, aren't you? So now we have it all became white. Let's add some colors, like, yeah, you can just modify this stuff to get unique colors for every vertex you wanna change. So just define them and make sure. And one thing I have to tell you, from here to here, this is a one vertex, right? This is a one vertex information: X, Y, red, green, blue. And now what we're gonna do is to create an attribute, right, like here, so our GPU can read it. First we have to load that attributes to our GPU, which we didn't done in the last videos. So we create a new object in GL unassigned integer VAO, which means vertex attribute object. Here we GL gen vertex array. Here we define one VAO and do this as much as just like buffer, but for a vertex array. Now we have to bind it. GL gen GL bind buff GL bind vertex array. Here we bind our VAO. Now we also copy it here. It will be binded, and we put it here down on the most bottom before creating while and after configuration, and put it here. So here we load our VAO to GPU in order to configure it in the start of program. Here we destroy it and basically make it empty, and while our program is running, it will be loaded. It's configuration. Here it will be read as configuration. Here it will be configured. You got it. So now here, first our attribute array. Here we have, as you know, 0 attribute array configuration. 2 will be read as or coordinates, GL float and normal as they should be. Here we write size of float and 5. What does it mean? We write it here, and it means that from here to here is considered one full vertex data, and here will be overall a 6, and this is a 1 we are selling. And this is one float, and we multiply it to 5, which means 5 of them are 1, and it will skip 3, this red, green, and blue, and jump here when reading it, instead of reading this as a x and y of next object. Now here it's this 0 because it implies that we read from here 1, 2, as here is a 2, and then other 3 is something this attribute will not touch. Now let's copy this. One. We put it 1, which means new array, right? New array with a new index, and here things stay as the same. Instead, we just change it here from 2 to 3 because we are going to read this 3, not 2. And to skip this, it must start from here to here. So we write like this: void and size float is multiplied to 2 because it says where to start. We want to start from here, not here, and we put void for this to be here, and it will jump to here and read from there. And when it comes to here, it also jumps to and starts from here. So as much as attributes are not ready, now we have to define our shaders themselves because we do not have a shaders. If we try to build it, nothing much happened because our shaders are not defined, and these two are, this is reading and this is sending data. These both are sending data to GPU, and OpenGL is using default instead of what we want it to do, as much as coloring stuff. So right now we are going to create a fragment and vertex shaders. So in the shader folder, you can open it. I will link my nvm configuration on my GitHub, and here we create our vertex shader. I'll end the GL cell and new. Let's create one fragment shader. It also will be jealous cell. Now fragment vertex shader we enter first. Here we write this version. Also I have to say that shader is a program that runs in your GPU, so it's a bit similar to C++, but also a bit different. So first layout, location 0, and vector to position. So what did I just wrote? First we are defining that from a location 0, which is our first attribute here, that gets these two coordinates, we get a vector to position, which means an x and y. Now 1 we create for a second one, which will be vector 3 because red, green and blue are colors, and we call it vertex color. So now what it is gonna do, it's going to read once per time what these two are going to give, right? If in the first run it will give this and this, it will take position as this two and vertex color as this. And now in main we also create a main function. Here we write like this. First we have to give take our position and put on a screen. Basically we just do GL position equal vector 4 and position. I also have to say that we write 0 and 1 here. I'll explain now. So we have a position which is a 2, x and y, but OpenGL itself works in 3D space, so we have to define z space as 0, which means we are doing 2D, and this one is for a matrix calculation like rotation and so on. You don't have to worry about that much. It's a GPU's thing to do usually, and you will get on it only when you're going to do a 3D, and not fully of course, because you can just use GLM but to know is better. And now here we also have to define out. What out does is it out, yes, output something. We define vector 3 color, no, fragment color. That's a frag color. So we are going to output a fragment color of vector 3. Now what we're gonna output is our vertex color as a fragment color. Let's do this. We do fragment color and define it as a vertex color and put a value. So now in our fragment shader we also define version for OpenGL to not to work, and we have to do this in which means we take from outside frag vector 3 frag color. Also here, when you're giving from here, yeah, where you're outputting frag color to fragment color, make sure names are same. Yeah, here I have to put a capital, or less it will not work. Now we did it, and out we do vector 4 color. It's for I'd say it is for alpha channel. Yeah, alpha channel. We did vector 4. It will be an output that GPU will read in order to draw stuff. Now we just define it like this. Color will be equal vector 4. Yeah, again fragment color, and for alpha channel we define 1. Now our two headers are ready, I suppose. Now we have to load them or make a shader programs itself. Writing a shader programs is kinda easy. First we have to define shader and vertex and fragment shader, then attach them to our program, shader program, and it will run multiple and at the same time on GPU, while our program in C++ will run in CPU. So what we're gonna do, first we have to get our two files to string form. To do this, we first you have to add these two, fstream and file system. It's a common thing that comes with your compiler. So now standard fstream, and we create vertex file, which will be our vertex shader. You can use whatever path you like, but I recommend you use like this because global path will never broke. No, not this. OpenGL. Now what we're gonna do is load this file to buffer. To do this, we create the buffer, which will be string stream vbuffer, let's call it. Now to vbuffer, we make vbuffer to read vertex file. Damn it. Read buffer, right? We will string stream to vbuffer or vertex files buffer. Now as we have vbuffer, we have to turn it on a string, standard string, and we have a standard string, let's call it vstring for vertex, yeah, and we get vbuffer, turn it on a string, and we turn it into character. Now we put constant, because constant means character will not be changed, because character cannot, it's hard to make character dynamical by default. And I do not recommend to do that, and string exists for that. Now we made a constant character, let's say it C vertex, which I assume you understand means character vertex. Now what we're gonna do is we take our v string. Wait a minute, why? let's let's turn it to C vertex. Oh god, C vertex is turned onto C string. Now this is gonna load our file, vertex file, all this to string, character string, and give us it. We will store it in a sys vertex, and we're gonna do same for our and we are going to do same for fragment shader. Make sure you will not forget anything, like make sure you're typing everything correctly. Because if you fuck up, and this will have variables from this block, it can crash. I recommend you to turn it on a new function if you can, if you're experienced. If you're not experienced, do not watch this video, go learn C++. So C vertex, it was a C fragment now, and here also. I suppose it works now. Now we have to create our shaders. Let's create them. It also is a OpenGL unsigned integer graphic library or whatever. Now vertex shader. Let's make it a big vertex shader, which will be GL create shader. Now we give it a type vertex shader and fragment shader. Let's rename it here. Now we just created shaders, but we have not attached our string to them. In order to do that, we have to first do this GL shader source here. We take our shader, which is vertex shader, and we give the size, which means we just want to do one shader, right? And string, which is our C vertex, yeah. And oh yeah, make sure it's a reference rather to not copy stuff. So, and length, which will be just 0. And we do the same for fragment. I think you understand how to do this, how to turn it on a function, class, or whatever you want, and it will be way better, and we are going to do that in the future when making a game. Now we have to compile it. GL compile shader, vertex shader, and fragment shader. After compilation, we just created two shaders, but they are shaders, not program, and they must run in a program that will be loaded onto our GPU. To do this, we just create a new GL unsigned integer. So shader program and GL create program, and we attach them. GL attach shader, and we have a shader program and our shader, which is right now vertex shader and fragment shader. Now we just have to link and GL link program and our shader program. Now it's finished. Now we just here in while loop, or just here, or in while loop, whatever, wherever you want. If you are making a several shader programs, like if you have a new shader for lightning, color, or final render and so stuff, you put your shader, this GL use shader, no, GL use program. Here we define our shader program, we give it a shader program, so it will use our program. Now here you have this, and you can either put it on a while, which means you can in time change what shader you're going to use, or here. Let's just put it here for sure, and let's try to run it. Well, we got an error, I guess, because it should not act such a way. Let's check. So see vertex, we buffer. Probably a fragment shader error. F buffer as fragment. Or a problem was here. Frag color. So I fixed some issues now. Here we have forgot that when copying vertex shader and turn it on fragment shader, and in here in a vertex shader we forgot to put an this, yeah, because this is important. Now let's build it. There's a syntax. Now here we have our colored cubic, yeah, colored rectangle. Let's play with its colors. So this two pink implies that this and this are same and next to each other, and here, which one is, and yeah, if it is this like, then we can change it here. Now let's try to rerun it. Oh yeah, as you can see, it became pink in the middle. Now thanks for watching, and next video we are going to make a textures, and later maybe can classes, so we can make a Flappy Bird and similar games. Thanks for watching, goodbye, and also subscribe.